Hello everyone. So this video is a continuation of our discussion on stoichiometry. We're going to look at dot point 14.2 now, which is using mole ratios to identify the excess, which I'm going to abbreviate as excess, and the limiting reagents. Oh, and extra point for anyone who get the meme for this lesson. All right, before we start, I just want to do a quick throwback at this game that I actually really like to play in, thinking of downloading and playing this weekend. I think this is called Burger Shop 2, according to the link. So let's say, for example, you need to make burgers. I wrote cheeseburger, but I realized there's no cheese in the burger I'm about to make. So let's say we want to make a burger for this customer who is feuding and getting very mad because, you know, if I were to play this game, this would never happen. So if you want to make this burger, you're going to need two of the buns. So let's say you need the top bun and then the bottom one. And then you're also going to need one of the chicken patty. So chicken in the correct order, I remember, that's very important. And then you need the lettuce. So you have the lettuce here. So those are the four components that you need for the burger. And if you look at the conveyor belt here, I only have one of the chicken patty. I have 3 of the bottom bun. So let's say this is component number 1 and then number 2. So you have the top bun and then you have the bottom bun. And then you have the lettuce, which is, I think that I said the, okay, lettuce is 3. And then number 4 is the chicken. So in order to make a burger, you need one of each. You need the top bun, the lettuce, the chicken, and the bottom bun. If you look at the conveyor belt, there is only one chicken patty available. So there is one of this. You have 3 of the bottom bun, and then you have 2 of the top bun, and 3 of the lettuce. Okay. So the question here is, how many chicken burgers? I know this customer only wants one, but how many chicken burgers can I make using all the materials shown in the conveyor belt? And the answer, hopefully, is that you get this correct, is I can only make one of these because I only have one of the chicken. So you can make one of the burger using one of the top bun, one of the lettuce, one of the chicken patty, and one of the bottom bun. So the answer is I can make one product out of this many materials that I have. And the reason why you can only make one of the product is because you only have one of the chicken patty, even though you have more than one of everything else. So the chicken patty in this case is called the limiting substance, or if you consider this to be a chemical reaction, when you have 4 reactants combined to make one product, the chicken patty will be called the limiting reagent. The limiting reagent is the substance that is present in the least amount according to the ratio, and it limits how much product that you can have. So because you only have one limiting reagent, you can only make one product. So the limiting reagent will limit the amount of product. So even though I have 3 of the lettuce, I cannot make 3 burgers. So limiting reagent limits the amount of products. And the amount of product is going to depend solely on the amount of the limiting reagent available. Now, after I have made this one chicken burger, kind of feel like burger now. Maybe I have a chicken burger for lunch. So you're going to have in excess one of the top bun, 2 of the lettuce, and 2 of the bottom bun left. So because you just use one of each. So the other 3 components, the top bun, the lettuce, and the bottom bun, these are called reactants or reagent in excess. I'm going to use the word reactant and reagents interchangeably. Maybe I should stick to a standard. So let's go with limiting reactant. And this is reactant in excess. So when you in an actual chemical reaction, normally what happens is you're going to have one of the reactants to be limiting, and it's going to control how much product that you can make, and then the other reactants potentially can be in excess. So this is just an analogy of what the difference between limiting and excess is. Highly recommend. It's a pretty fun game, especially when when you make the ice cream. Okay, maybe you shouldn't waste your time on these things, but so similar to the last worksheet, I'm going to go through a few questions here and discuss the different types of questions that can be asked. I think I'm only going through 3 questions this time. I did go through 3 last time as well. I don't know. I think I went through 4 last time. I can't remember. Anyway, this is question 1, so it is the same question as the one in the worksheet. So if you print it out, this is the first question. So just have a read. So we have 0.25 mole of sodium hydroxide. So the number of mole of NaOH provided is 0.25. And you also given reacts with 0.75 mole of HCl. So the number of mole of HCl given, so I have 0.25 and then 0.75. This is 0.75. So this is an acid-base or neutralization reaction, and the equations given to you here is already balanced. The question asks you to identify the limiting reagent and determine the number of moles of reagent in excess. I may actually use the word reagent throughout. You can use reactant, it doesn't matter, but I think the question actually says reagent. So you need to work out which one is limiting. This is my normal abbreviation for limiting. I just write LR, so limiting reagent or limiting reactant, either is fine. And the amount in excess. So this is what I write sometimes. And in excess or excess is how much is in excess. So in order to determine what reactant is limiting and what is in excess and by how much, you need to be able to establish a mole ratio. So if you go back to this example, the reason why I know that the chicken patty is the limiting reagent is because I know the ratio between each to make a product. So if I want to make 1 chicken burger, I need a 1 top bun, 1 lettuce, 1 bottom bun, and 1 chicken burger. So the mole ratio between the 4 reactants, as shown in the picture of the product, is a 1:1 to 1:1 ratio. So in that case, the substance that is in the smallest quantity must be the limiting reagent. Now, if you have a chemical reaction, the chemical equation is going to give you the mole ratio. So if you look at the mole ratio between sodium hydroxide and hydrochloric acid, that is a 1:1 ratio. So from equation, 1:1 mole ratio is the easiest to work with because it's very easy to tell which one's limiting. So from the equation, the number of mole of NaOH and the number of mole of HCl is 1:1, which is another way of saying that if the reaction is complete and everything is used up, so there's nothing in excess, the amount of sodium hydroxide would equal to the amount of HCl. So if I have 0.25, so if I have 0.25 mole of NaOH, so if N of NaOH is 0.25 mole, you're going to require N of HCl to be 0.25 mole as well. So if you have 0.25 mole of sodium hydroxide, you're going to need 0.25 mole of hydrochloric acid to completely react with it because of a 1:1 mole ratio, which just means that the two number of moles are equal to each other. However, in reality, you given 0.75 mole of HCl. So the amount of hydrochloric acid that is given is more than the amount required, which means that hydrochloric acid, so more than required. Which means that hydrochloric acid must be the substance in excess here, and sodium hydroxide must be the limiting reagent. So HCl is in excess, and NaOH is the limiting reagent. So the first part of the question is to identify the limiting reagent, which is sodium hydroxide. The second part of the question is to determine the number of mole of reagent in excess. So we know that hydrochloric acid is in excess. Now we need to know how much of it it's going to be left over after the reaction is finished. So it's similar to this. So after I've made 1 burger, I still have 1 top bun, 2 lettuce, and 3 bottom buns left. How much hydrochloric acid do you still have left? And if you only need 0.25, but you have 0.75, the difference between these two is going to be the amount that is in excess. So the number of mole of HCl in excess, it's going to be 0.75 minus 0.25, which is 0.50 mole. So sodium hydroxide is the limiting reagent. Hydrochloric acid is in excess by 0.5 mole. So by the end of this reaction, beside these two products, I also have 0.5 mole of hydrochloric acid left over as well. Let's put HCl in excess. Okay, so that's 1A. Let's make things a little bit more interesting when you have the mole ratio that's not 1:1. So the question is the same. I gave you the amount of reactant and you have to determine the limiting reagent and the amount in excess. So the number of mole of hydrogen gas given is 1.25 and the number of mole of oxygen given is 1.75. Once again, you need to find which species it's limiting and the number of mole of the substance in excess. I don't know which one is in excess, so I can't write in which one it is in the bracket yet. Okay, so once again, we're going to start with the equation. The mole ratio from equation is, and this is entirely up to you. So I'm just going to start with H2. So H2 over O2, this is a 2:1 mole ratio, okay? Now, because it is a 2:1 ratio, it is a little bit harder to know which substance is limiting and which is in excess. Because if you go back to part A, it's very obvious that the substance that has more is going to be the substance in excess because you start with a 1:1 mole ratio. So the two reactants are supposed to be equal to each other according to the ratio. However, this one, the ratio is 2:1, so it may be a little bit, actually no, it's actually not that hard. In some situations, it may be a little bit hard to tell. So let's just assume that I can't compare these two numbers. If it's not obvious to you which one is the limiting reagent and which one is in excess, what you can do is you can just assume that one of the species is limiting and then work out how much of the other species is required to completely react with it. So I'm going to step one is to assume a reactant is limiting. I'm gonna is limiting and phi. Actually, let's just okay. Let's just do it one step at a time. So assume a reactant is limiting. So not that I know what the answer is supposed to be, but I'm just going to assume that H2 is limiting. So assume H2 is the limiting reagent. Now, once you have made this assumption, and this is a process of try and error, okay? You may assume that oxygen is a limiting reagent, and your assumption may be wrong, but what we're going to do is once we make an assumption, we're going to test whether the assumption is correct or not. So step two is we're going to use mole ratio to determine, I can't spell, determine N required of the other substance, of the other reactant. So if I have assumed that hydrogen is the limiting reagent, I'm going to use the number of mole of hydrogen that is given to me, which is 1.25 mole. And then I'm going to test to see, okay, if I need to completely react this 1.25 mole of hydrogen, how much oxygen do I need for that complete reaction? And this is where the mole ratio comes in. So if you use mole ratio, you know that NO2 over NH2 is going to be a 1:2 ratio, looking at the equation. So the number of mole of O2 required, this is not the amount that's given to you, this is the amount that's required as stated in the question. So NO2 require, it's going to be half of NH2, which is a half of 1.25, which I can't do math anymore, so let's just use a calculator. So 0.625 mole. So in order to completely react with 1.25 mole of hydrogen, you need 0.625 mole of oxygen. And step 3 is to compare the amount that is required with the amount that you actually have. So compare require and given. Okay, so if you compare these two values, you can see that the NO2 given is actually 1.75 mole. So obviously you are given more than the amount required. I need to create another slide, actually, give me a second. So the amount given is more than the amount required. Therefore, oxygen is going to be the substance in excess in this case, and hydrogen is actually the limiting reagent. Okay, this is not a good time for my slide to be not responding. All right, so let's do that. And then we have one more. Let's go back to this. Okay, let's recap what I just said. So the amount given is greater than the amount required. So this is just continuation of question 1b. So NO2 given is greater than NO2 required, which means that O2 is in excess, and you can even work out the amount that is in excess. The number of mole of O2 in excess is going to be the amount given minus the amount that is required, which is the amount that you will use, which I think was 1.75 minus 0.625. Again, haven't had coffee, can't do any maths. So I'm just going to use a calculator to get 1.125. I feel like I should do this by hand, but anyway. So this is the amount in excess, which is one of the two questions. The other question was, what is the limiting reagent? So H2 is the limiting reagent. Now, if you do this comparison and the amount given turns out to be less than the amount required, then it means that that substance is not in excess. Okay, let's do one more example. And we're going to use a more interesting mole ratio. The mole ratio here is a 3:8. And let me see whether, yes, okay, I should be able to make the assumption that's not right here. So the number of mole of H2, Hg, or mercury, is 0.27 mole. And the number of mole of HNO3 is 1 mole. Once again, you need to determine the substance that is the limiting reagent, and you need to work out the number of mole that is actually in excess. So two things that you have to do. I'm going to start by just assuming, and this is an assumption, so it may be wrong. So I'm going to assume that Hg is limiting. So that's step 1, make an assumption. Step 2 is to work out how much nitric acid, how much HNO3 would be required to completely react with the mercury. So I'm going to find N of HNO3 required using mole ratio. So the mole ratio given in the question is an 8:3. So the number of mole of HNO3 required is going to be 8/3 times the number of mole of Hg, which is going to be, so this is required, 8/3 times, what was that, 0.27? Okay, moment truth. So I get 0. Oh no, it's still, I still pick it correctly. Okay, 0.72. I thought that it's actually not the substance in excess. So the number of mole of HNO3 required is 0.72 mole. Now the next step is to compare the amount required and the amount given. So NHNO3 given, you're given 1 mole of HNO3. So you actually given more than the amount required. You only need 0.72, but you're given 1, which means that HNO3 is in excess. And you can also work out the amount in excess. So the amount in excess is going to be given over required. So 1 minus 0.72, which is 0.28. I think my brain start working, so I can do some math now. Let's hope I didn't do that wrong. So that's the amount in excess, which is one of the questions. And you can go back and say that mercury is indeed the limiting reagent, which is the other part of the question. So limiting reagent is mercury. Okay, so that's limiting and excess. Now, if I'm just going to go through another thing. So if the question asks you to let's say determine the number of mole of nitrogen oxide that can be produced. So let's say there is an extra step and I need to find N of NO produced. The only thing that you need to do when you determine the amount of product is you need to use the number of mole of the limiting reagent. So need to use the limiting reagent to find amount of product. Because the other substance is in excess, so you're not using all of it, so the mole ratio is not going to be correct, so you need to use the limiting reagent. So if I want to work out the amount of product, which is NO here, I am going to need to form a mole ratio between NO and mercury, which was the limiting reagent. And this mole ratio is once again from the chemical equation. So it's a 2 to 3 mole ratio between the two, which means that the number of mole of NO is 2/3 times the number of mole of mercury, which is 2/3. I can't remember what the original 0.27. Okay, so 0.27 times 2 and divided by 3, you get, so the number of mole of NO is going to be 0.18. Okay, so if you need to find the amount of any product, this is what you should do. So that is that. I was going to go through more questions, but I think I'm just going to repeat myself. So it's probably a good idea to try the rest of the questions yourself. Most of the questions are pretty straightforward, except when you get to, I would say, number 8. That's when it starts to get a little bit trickier. So when you get to question 8, just jump into the mid and ask me. 8, 9, 10 are pretty challenging. But other than that, you'll be fine. It just takes practice. Okay, thank you.